In this video, I would like to show you how you can calculate the kinetic energy of an object that is moving in a circle. The first thing we see in this video from simulation from Physics Aviary is that this ball is spinning in a circle that appears to be going at a relatively constant speed. So if we would like to calculate its speed, we are going to need to make a few measurements. Now, the equations that we're going to use in this simulation are based off of these two. We have the speed of an object moving in a circle is 2 pi r times the number of circles divided by the time it takes to do those circles, and the kinetic energy of a moving object, which is 1/2 mv squared. So that means a few measurements are going to need to be made. The first thing we saw is that we needed to calculate the speed by making the measurement of radius, and all I need to do is place my mouse at a particular location and just estimate a few times. It appears that the center of the ball is going right where my arrow is, and if I look down, that this is about 1.1 meters. So I now have my first measurement. My second measurement that I need to make is the number of laps divided by the time. Now, in this simulation, one of the problems that students have is that they just time one lap. And that causes an issue with error because we have to time it perfectly at the start and time it perfectly at the end. And each little bit of timing that we miss with the timer is going to have an impact on it. So we'd like that to have less impact. So what we should do is time it for a longer period of time. So instead of running just one lap, we'll run multiple laps. Now, I've already hit the timer button here. I actually timed 5 laps, and the 5 laps took me 14.33 seconds. So that gave me 2 more variables that I could use. Just to show you how this would work, though, I could click here, and I can now reset the timer. And if I would like to, I'd pick an easy spot, such as here. And what we'd see is that that would be the time of 1 lap. But again, that error that's present because of trying to click carefully twice, both of those time errors that I had here in my delay and my wait time is only happening over a 2.78 second time interval. So if I were to let this run for a lot longer time, then that little bit of a delay won't have as much of an impact. It would be, that amount of time out of 14 seconds rather than that amount of time out of less than 3 seconds. So looking back at our equation, we now see that we would be able to calculate the speed using 2 pi radius times 5 laps divided by the time. And if I run this calculation out, I see that I would get about 2.41 meters per second. Now it's time to use the kinetic energy equation, and that means we need one more measurement because we now see that we have the speed, we just need the mass. So if we go back to the simulation, measuring mass on a simulation obviously is not very easy, but we do have some information here in the question. And when we click on it, we see that the object that was spinning does have a mass of 899 grams. The only issue with this number, and a common mistake that students make, is that they forget that this needs to be in kilograms. So we'll need to divide it by 1,000 to turn it to kilograms. So it'll become 0.899. Now that I know that, it's time to solve out the kinetic energy. I would just take that mass that I just observed, times it by the velocity. Don't forget to square. A lot of students forget about the squaring. And if I do that, I should be good to go. And running my calculations, I see that I would end up with 2.61 joules. So let's see how this goes. All right, not going to put my name in, but I did see that I had 2.41 meters per second. Please don't enter meters per second. It's already there. And don't enter joules. It's already there. So now I just need to type in 2.61, and hopefully it is right, holding our breath. And we see that our calculations are correct. I'm off by a tiny little bit here. I have heard students complain about this simulation in that the tolerance is a little bit low here. So sometimes it will say that you're incorrect even though you're pretty close. If you see it, your speed is good and that this is pretty close, and it does say it's incorrect, I don't need you to rerun the whole entire activity, but just giving you a heads up on this one. This one's a little bit less tolerant than some of the other sims that we do. Hopefully this lesson was helpful in helping you solve the kinetic energy of an object moving in a circle. Stay tuned for more videos from our physics classroom.